Hi everyone. All right, let's get this practice test underway here. All right, a word problem on the first one. Casano's Pizza pays their delivery person a base amount plus a certain amount for each pizza they deliver during a 6 p.m. to midnight shift. On one shift, the delivery person delivered 30 pizzas and made $80.20. On another shift, the delivery person delivered 41 pizzas and earned $88.34. Write a linear equation for the delivery person's wage, W, in terms of the number of pizzas delivered, P. Explain what the slope and y-intercept, probably should be w-intercept, are in the context of this problem. So P is the number of pizzas delivered, W is the wage that the worker gets. We do have a couple of those relationships there. 30 pizzas goes with $80.20, and 41 pizzas goes with $88.34. All right, we ought to be able to get an equation when we know 2 points. So let's first of all go for the slope. And let's take the $88.34 minus the $80.20, y2 minus y1 over x2 minus x1. What is that? $8.14 there, divided by 11. Let's take 8.14 divided by 11. I'm getting 0.74. That's 0.74. And in W equals MP plus B, I'll put the $80.20 in for W, the 0.74 in for M, and the 30 in for P for number of pizzas, and go plus B. Let's see, 0.74 times 30 is 22.2. 22.2 plus B equals 80.20. And if I subtract the 22.2 and subtract 22.2 here, I'm getting B is, it's like 58. So W equals 0.74 times P plus 58. All right, the slope is 0.74. And that is how much he gets per pizza. So he gets, I'm trying to think how to just say that, 74 cents per pizza delivered. Is the slope. Distinguish that. And we also put around the equation here the W-intercept. Okay, that $58 is the W-intercept and represents the base amount. So he gets $58 for coming in, and then 74 cents addition for the pizzas he delivers. All right. Now number 2. It says give the equation of the line that is perpendicular to the line with equation y equals 5 and passes through the point negative 9, 12. So if I go negative 9, negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9, 8, 9, 10, 11, 12 is like right here. So I got a line passing through that, and it is perpendicular to y equals 5. All right, well, y equals 5, 1, 2, 3, 4, 5, is this line right here. That's y equals 5. So we're talking about this line right here. And it is vertical. It's hitting the x-axis at negative 9, so x equals negative 9 would be the answer there. All right, number 3, give the equation of the line that is parallel to the line with the equation 7x plus 2y equals negative 1 and passes through 7, negative 2. So my strategy is figure out the slope of that one. 7x plus 2y equals negative 1. If I subtract 7x from both sides, I got 2y equals negative 7x minus 1, and divide through by 2, I've got y equals negative 7 halves x minus 1 half. And what I wanted from there was the slope. The slope is negative 7 halves. The line, that's the slope of this line. It is parallel to the line we want, so the slope, we're going to use that negative 7 halves, and I'm going to put negative 7 over 2 here, 7 for the x, because we're passing through 7, negative 2 for the y, and go plus b here. Got negative 2 equals, okay, I think that's negative 49 divided by 2, which is negative 24.5, or negative 24.5, plus b. If I add 24.5 here, and add 24.5 here, I'm getting b equaling 22.5. So my equation is y equals negative 7 halves x plus 22.5. I'm just giving it in slope-intercept form. Didn't tell me to do otherwise. All right, number 4. Find the function value for the following function. So we got a piecewise function. F of negative 7. We would use this first one because negative 7 is less than or equal to negative 1. So we take negative 7 minus 1. I plug it into that one, which is negative 8. F of 1. 1 is between negative 1 and 3. So I'm going to use this next one, and I'll take 3 times 1 minus 5. 3 minus 5, that's negative 2. F of 3. All right, I do not use that one. 3 is not greater than 3, so I'm going to go back up to that one. And I'm taking 3 times 3 minus 5, which is 9 minus 5, which is 4. All right, 4 is done. We are going to graph this function. I'm going to draw a line, vertical line here at negative 1 for that boundary, and I'm going to draw one at 3 for that boundary. So left of negative 1, negative 1 and left. For the first piece, I'm going to use -1 and go smaller. -2, -3. Y equals x minus 1. So -1 minus 1 is -2. -2 minus 1 is -3. -3 minus 1 is -4. And this one, because of this, gets the dot. Gets the closed circle. So -1, -2 is right there. -2, -3, -3, -4. So I'm getting veering off here a little bit. There's the first piece. The second piece will happen between -1. That one will be open though. -2, oh no, I don't want to go that way. -1, 0, 1, 2, and 3. It stops at 3. 3 will be the closed end of that interval. -1 times 3 is -3 minus 5 is -8. So -1, -8, 0, -5, 3 minus 5 is -2, 6 minus 5 is 1, and 9 minus 5 is 4. So -1, -8, 3, 4, 5, 6, 7, 8. 0, -5, 1, 2, 3, 4, 5. 1, -2. 2, 1, and 3, 4. 1, 2, 3, 4. Okay, that is linear, that piece of the function. Now the last part of the function is not linear, it's curved a little bit. So x and y equals, I'll get as much of that as I can on here, x squared minus 3x minus 1. And it starts at 3, but that'll be open. So I'm going to take 3 squared, which is 9, minus 3 times 3, which is 9, minus 1. 9 minus 9 is 0, minus 1 is -1. Let me put 4 on here. That's 16 minus 12 minus 1, which is 3. Let me put 5 on here. That's 25 minus 15 minus 1. That's 10 minus 1. That's 9. That's about all I'm going to get on there. So that gives me a good idea of where to start. So 3, -1 is an open circle. 4, 1, 2, 3 is here. 5, 4, 5, 6, 7, 8, 9. 5, 9 is right there, and that's curved. It's not linear. I want to make it look a little bit of a curve, of a parabola. All right, there is the piecewise function graphed there. All right, number 6. Find all of the values of x for which f of x equals g of x. F of x is this, g of x is this. Square root of x minus 6 equals 12 minus x. Well, let's square that. Let's get rid of that radical. And that's x minus 6. That is, you can FOIL it if you want, 12 minus x times 12 minus x. I've done enough of these, even this year. I'm just starting to use the pattern. 2 times 12 times negative x is negative 24x. And then plus x squared there. All right, looks like we got a quadratic to solve. So I'm going to subtract x here, subtract x here. I'm also going to add 6 here and add 6 here. And that gives me 0. That all gives away. And 144 and 6, well, let me write the x squared first. Negative 24x minus x is negative 25x. 144 plus 6 is 150. Oh, that's 25 times 6, 30 times 5. I'm not thinking that's going to factor, so I'm going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. All of that over to a. Actually, I think it might have factored if we'd have tried a little harder. So it's 25 plus or minus square root of, I think that's 625 and that's 600. I think that's 25 there. I am going to check though. I don't want to. So negative 25 squared minus 4 times 1 times 150 is 25. All right, that would have factored. I just didn't look for it hard enough. So x equals, because this is a perfect square, 25 plus or minus 5 over 2, and 25 plus 5 over 2 is 30 over 2, which is 15. And 25 minus 5 over 2 is 20 over 2, which is 10. 15 and 10, oh yeah, 15 times 10. 15 plus 10 is 25. All right. That would have factored. But you might need to use quadratic formula. It may not come out quite as nice when you're doing your own tests. So just be ready. And let's see. And if it doesn't come out evenly, I may not have put in the instructions, but I'll allow you to just round to the nearest hundredth on those if we have to. So I do want to check. 15 minus 6 is 9. So square root of 9, does that equal 12 minus 15? Uh-oh. No, that's 3 and that's negative 3. This one is extraneous. Okay, 10 minus 6 is 4, square root of 4. 12 minus 10 is 2. Square root of 4 does equal 2. This is the solution. X equals 10 is the only solution. All right. Number 7, give the domain of the following functions. F of x equals the square root of 3 minus 2x. All right, we cannot be negative under the radical. So 3 minus 2x has to be greater than or equal to 0. I think I'm going to solve that inequality. 3 minus 2x. We've got to keep that greater than or equal to 0 under the radical. And if I subtract 3 here and here, I got negative 2x is greater than or equal to negative 3. And then I divide by negative 2, and I've got x is, all right, when I divide by negative, I got to switch that around. X is less than or equal to 1.5. So that less than or equal to negative, so negative infinity to 1.5. Oops, always use that around infinity. And it's including 1.5. Okay. The second one, the denominator, x squared minus 1 cannot equal 0. That's x plus 1 times x minus 1 when you factor that. Cannot equal 0. That means x cannot equal negative 1 or x cannot equal 1. Cannot have those two values. If I did interval notation, I'd go negative infinity to negative 1, negative 1 to 1, not including the negative ones, and not including the 1, and then 1 to infinity, if I used interval notation there. All right, this next one, h of x equals square root of x minus 7 over x minus 11. Okay, we know x minus 7 has to be greater than or equal to 0. So x has to be greater than or equal to 7, and x minus 11 is not equal to 0. So x is not equal to 11. Greater than or equal to 7 and not equal to 11. You can represent that. Interval notation would be best here. We can have 7. We can go up to 11, but we can't equal 11. So we could represent it that way. All right, number 8. Determine the open intervals for which this function, f of x equals the absolute value of x minus 3 times the absolute value of x plus 2, is increasing, decreasing, or constant. Okay. This would be one where you could use Desmos or your graphing calculator on. If you need to do absolute value, pay attention here. It's math, it's num, and it's number 1. That's math, num, and then the first function is the ABS function. Okay, x minus 3. Oops, I want y equals. Oh, guess what? I got it. I'm going to clear it just so you can see it put in. And oh, there's the greatest integer function too. Math, over to the num, the ABS. Let's do x minus 3 times math, num, ABS, x plus 2. Okay, I'm going to graph that. I got a standard window on. All right, interesting. Very interesting. Okay. It is decreasing here, increasing here, decreasing here, increasing here. So let's do the decreasing parts first. From negative infinity to this point right here, would it hit 0? I'm pretty sure that's negative 2. I'm going to just do a quick calc of that just to show you. There's a 0 function there. I want to go left of that 0, so I'm over here. See, the x is negative 2.5. And then go right, hit enter, and that's negative 2, 0. So from negative infinity to negative 2, it is decreasing. I'd really like to find what that maximum value is there. So I'm going to go second calc, go to that maximum value, put that cursor there for the left side, get up to the top and come back down a little bit to the right side, hit enter, on the guess. I'm going to use 0.5, I think it's rounding, 0.5 and 6.25. Is that maximum. Okay, we're looking on the intervals of x. I'm negative 2 to 0.5. It's increasing, but that 0.5 until we get to 3. This is 3. I could do that 0 again, but it's the 0 is caused by this absolute value. So I'm going to go 0.5 to 3. Those are the decreasing units. The increasing, we've got enough information here. Intervals are the negative 2 to 0.5, increasing intervals on x, and the 3 to infinity. Okay, just using the graphs for that. Now, number 9. We're going to use this graph, and this might be another one where you want to use Desmos or and do practice that using your technology so you don't have to waste time when you're on the test. Make sure you practice this on your calculators. So, number 9, I'm going to draw an accurate graph, find the relative max, relative mins, zeros, and the intervals for which f of x is greater than or equal to 0. So, let me put this in. I'm going to clear that. I'm going to put that in. I've got y equals x to the third minus 3x squared. Whoa, 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 you didn't. Okay. Let me delete that. Delete that. Okay. Now, let me press this. Okay, I didn't bring it back down out of the exponent. Minus 3x squared minus x plus 1. Okay, I got a standard graph on right now. Okay, that is an interesting looking graph. I'm going to answer where this max is, this min is, and where these zeros are. I want to find all that information out first. So, I'm out of focus here. Come on. Focus. All right. There we go. All right. So second calc, we got a max that we were going to look at, right? Yeah. Let's go here to the left, enter. Here to the right, enter, enter. So negative 0.15 and 1.08. Negative 0.15 and 1.08. We have a relative max there. Let's get this minimum. Second calc, minimum. Okay, hit enter for the left, hit enter for the right, and I got 2.15 and negative 5.08. All right, the zeros of this thing. All right, here's a 0. I'm going to get the far left one first. So on the left of that 0, hit enter, enter. I'm right of that 0, hit enter, guess, and negative 0.68. This is all pretty, gonna be squished in there pretty good. Now let's get that second 0. Second calc 0. Okay, I'm left of it. On this one, I'm left of it is above it. I'm right of it, now I'm below it, the line. So that's 0.46. A lot happening right around the axis there. And then let me get that last 0. Second calc 0. Okay, I'm left of it. I'll come back down here. Right of it. Hit enter. 3.21. I get 3.21. So, I'm going to put let me put that first maximum on. Well, let me put the first 0 on. Negative 0.68 is right here. This is too small. 0.46 is right here. 3.21, 1, 2, 3.21, I'll put right there. I'm going to put my max up at negative 0.15, 1.08. So right around here. And my min here at 2.15, 2.15, negative 5.08, 1, 2, 3, 4, 5, just slightly below that there. And then, so it comes up, hits that peak, comes down here, hits that, and then goes up like that. Okay, that's fairly accurate graph. We've got the important points on it. Now, when is f of x greater than or equal to 0? It is right here, it's greater than or equal to 0, and right here. So between these two zeros here is negative 0.68 and 0.46. And after 3.21, so from 3.21, draw that a little better, to infinity. Okay. Now, number 10. Determine whether the following functions are even, odd, or neither. Justify your response either algebraically or graphically. All right. I'm going to try f of negative x on this one. Negative x to the third minus 5 times negative x. Negative x to the third, a negative times a negative times a negative is negative. Get rid of the parentheses. And negative times negative, that's positive 5x. That is the exact opposite of f of x. Okay, so f of negative x in this case is equaling the opposite of f of x, which means it is odd, and that means it's symmetric over the origin. Okay, make sure you study that. Odds are symmetric over the origin. Evens are symmetric over about the y-axis. Now this one, I've got g of negative x equals negative x squared minus 4. And g of negative x will equal negative times negative, that's positive, x squared, and then I still have that minus 4. So g of negative x is equal to just the same thing as g of x. Nothing changed there. So that's an even one, which means it's symmetric over the y-axis. I had to think for a second there. All right. Let me look at h of negative x here. Cube root of negative x minus 4, which equals, if I go negative x plus 4, I'm not getting anything here. Now a negative, a cube root of a negative is negative. Cube root of like a negative 1 is negative 1, so I just pull that negative out. And that's not the opposite of that. Don't forget that cube root. I think this one is a neither. And if you wanted to check, just to see where the symmetry would be, you could just put in y equals, let me clear the last one out, and the cube root, which is math, and number 4 down here is actually a cube root, and put x minus 4 in underneath that. and look at that graph. Okay. Doesn't look like it's symmetric about the origin. And it's definitely not symmetric on the y-axis there, so it's neither. All right. Last but not least, use the following. This is our greatest integer function that we're going to use. And we're going to take 2.4 minus 1 and then add 1 to that. So 2.4 minus 1, that is 1.4, and that is 1. This is 1 plus 1, which is 2. Now 1 and 7/8, that's 2 and 7/8 inside the function, and then plus 1 inside the GIF there. And that is 2 plus 1, which is, no wait, it's minus 1. It's 1, it's 0 and 7/8. It's just 7/8 minus 1. So that's 0. And 0 plus 1 is 1. 0.75 minus 1 is negative 0.25. And we got to add 1 to that. And negative 0.25, that actually goes to negative 1 plus 1, which is 0. Now negative 2 minus 1 is negative 3. And then plus 1. GIF, the greatest integer function of negative 3 is negative 3. If it's an integer, it stays the same. So negative 3 plus 1 is negative 2. And 3. 3 minus 1 is 2 plus 1. So that's 2 plus 1, which is 3. If we graph the function, okay, I'm going to use a transformation. You know the parent function would be here, right? So I'm going to shift this thing right 1 unit and up 1 unit. So this goes right 1 unit and up, and I know right from left. Okay, so I'll put that right there. That's where the first one shifts. Now I'm noticing something here. I don't know if you're noticing it too. This is the exact same. That wasn't intentional. But this is the parent function too. It essentially we kind of slid it onto itself by doing this, because when you go to the next one, you're going right 1 and up 1. So it is the same thing as f of x equals GIF of x. All right, there it is. Good luck on this thing tomorrow, guys.